Welcome to High Tech in the Heartland. I'm Bob Gough, and I'm with Scott Richardson, and we talk about all things tech in the Midwest, and Scott's going to give us his quick disclaimer.
My disclaimer is, first of all, the mere fact that you're listening to this doesn't mean that I'm giving out legal advice because you're not my client. This doesn't form a client-attorney relationship. And also, I work for an East Coast law firm, Robinson Cole, and I'm not representing Robinson Cole with my remarks here. These are not their positions. I'm just speaking as a private citizen who's interested in high tech in the heartland.
And today's topic is what?
Well, first of all, Bob, have you heard the sentence, was it a car or a cat I saw? Have you ever heard that sentence?
No.
It's kind of a famous sentence, but that, in a roundabout way, that has to do with the technology I'm going to talk about today, which is CRISPR. And CRISPR stands for Clustered Regularly Interspersed Short Palindromic Repeats.
So we're not talking about the CRISPR in your fridge?
No, it's okay. Not like the CRISPR. It's much, much smaller than that. It's actually a molecular DNA splicer, or DNA editor, I guess you'd call it. And I said clustered regular interspersed short palindromic repeats. That sentence, was it a car or a cat I saw, is a palindrome. Backwards and forwards.
Okay.
Backwards and forwards. And the CRISPR DNA segments, it's these repeats, there's like a repeat and then a spacer, and then a repeat and a spacer of the bases in a DNA strand. The repeats are the same, and then the spacers separate them. Mm-hmm. But they're palindromic in as much as each of the repeats has a bunch of bases, like there are bases along the strands of DNA, and the bases are in a certain order on one strand of the DNA, and then they're in the opposite order on the other strand, and so they're palindromic. They go in one direction on one strand and the other direction, so palindromic. But I don't know if you wanted to know that detail, but anyway.
Well, no, I did, and I want to know what this technology is about. Because when you're talking about splicing DNA, you're talking about some really, that sounds, could be it could be problematic.
It could be problematic, yeah. There are a number of concerns and ethical concerns as well, but it's kind of a remarkable technology. And actually, we didn't really create this technology. We hijacked it from one-cell microbes. And one-cell microbes used CRISPR as a defense mechanism against viruses. Mm-hmm. And what they would do is they would snip out a piece of the virus and create RNA as basically it's a copy of some of the DNA strand of the virus or whatever. And then it would use that to identify the virus, and then it would use that to attack the virus within the microbe. And scientists realized what was going on with that, and then they hijacked that technology and made it into a tool to be able to go into any animal or plant's DNA, basically, and either snip it and remove a segment of the DNA, or else replace it with another segment. So they can actually express genes that weren't previously expressed.
You know, I saw this on Iron Man 3, and all the guys developed these powers where they became these crazed supervillains who could emit heat from their limbs. So I hope it's not like that.
Well, I tell you, those Marvel movies are ahead of their time.
They really are.
They make a Marvel movie, and then a few years later, we figure out how to do that.
Yeah.
That's pretty crazy.
And that's exactly the kind of stuff they were talking about in here. You know, Tony Stark and whoever. And yeah, it was so more of this, yeah.
And again, my background is electrical engineering and telecommunications and such, and I was a patent examiner in the patent office and some of those in the cell phone. So I'm not a biology guy at all. You'd have to have a graduate degree in biology to understand completely how this works. I just have a top level understanding, if that. I have about a dinner party conversation level of speaking to this topic. But CRISPR, and it's actually CRISPR-Cas9, and Cas9 is the protein that they found works best for CRISPR. And the Cas9 protein is actually the part that snips the DNA. And then it also has guide RNA, and that's what they use to match up to the DNA that they want to snip. And it's amazing, you see all these, you watch YouTubes and research it or whatever, and it's like these things just happen automatically. And it's like, I think I think even our best scientists just have a top level understanding of how this is working.
So I see the benefits, because if there's a way if you have some sort of genetic problems, like say your family line is you know, cancer,
sickle cell anemia.
cell runs in your family.
Yeah.
Some kind of cancer runs in your family. That if you could go in and take that out, that sounds like a good thing.
The thing is, you can't, like, we have, I don't know.
You can't identify what it is.
We have many trillions of cells in our body, and like a human that's already there, you can't go in and change every cell in a body. But what they can do is, like the zygote or the sperm and the egg, they can change those, and then whatever animal is formed from that will have those characteristics that they've changed, that they've edited, the DNA. That said, I mean, like for blood, you can grow blood and replace blood with new blood that doesn't have sickle cell anemia. And sickle cell anemia is one area that looks like they might be able to find a cure for this, for use. And then also HIV. And I didn't realize this, but HIV actually, when it infects a person, and it's before you come down with symptoms, but it deposits some of its genetic material. The HIV virus deposits some of its genetic material in your DNA. It puts some RNA there, which is like a placeholder for where it's going to go in. And apparently they can.
So are you saying it can be passed on to kids if people have HIV?
It can be, yes, it can. And in fact, I'll just skip over. I was going to talk about the inventors for a little bit, but I'll talk about this kind of interesting guy from China. And this guy, John Cui, there are huge ethical considerations in this, and so it's tightly, just a few. But this guy counseled some parents in China, and the father had HIV and the mother didn't, and they wanted to conceive, but he counseled them to let him introduce some CRISPR editing to the genetic material that was going to become their children, and they ended up having twin daughters, Lulu and Nana. And what he did is he removed the CCR5 gene from those embryos, and those became human beings eventually. These are CRISPR edited children, and they were this is like the first one in the world. And also, he kind of
How old are those kids now?
2018, so
Okay.
they're 6 years old,
Okay.
or 7 years old.
Okay.
And they're both living. One of them may have issues. She may have mosaicism, which means that she's basically a chimera, which means that she may have she may have two different sets of DNA in her body. And it's kind of a rare condition, and it's kind of chimera came from Greek mythology, where you'd have like a lion with a horse's head or something, two different animals.
Right.
But one twin may have that. They're not disclosing whether she does or not, but they're both alive, both living, and apparently was successful on the other one. But anyway, this guy got in a lot of, well, first of all, he didn't publish his findings in a scholarly journal article like most people do. He announced it on YouTube.
Well, that's the way of the world these days.
I guess it is, and that's kind of ironic because YouTube is not air. You can't get YouTube in China. When you go to China, YouTube is blocked.
Really?
So I don't know why he did it on YouTube, I guess.
Because he didn't want it to be seen in China. He wanted it to be seen outside of China.
Yeah, and also when I say hot water, he got put in jail for 3 years, in prison for 3 years for practicing illegal medicine. So, so there are, to answer your question, there actually are living gene-edited children, CRISPR-edited children.
So who discovered this? You were going to talk about the inventors. Or what have you.
Jennifer Doudna and Emmanuelle Charpentier. And those two women actually published a paper in 2013, and there's a bit of controversy as to who invented it, because there's another inventor, Feng Zhang, Dr. Feng Zhang, and he's associated with MIT and Harvard, and he published a paper shortly after that, and then the two women filed for a patent, and he filed his patent shortly after that. But there was a huge patent battle in the 10, 15 years ago, or 10 or 12 years ago over this, because They filed, and then he filed 6 months later, but he paid an extra fee to move him up to the front of the line to have his patent application fast-tracked, which, I mean, I was thinking about that, and as a patent attorney, I'm thinking, why wouldn't the two women do that? I mean, this technology is worth literally billions of dollars, and they just filed a regular application. They didn't fast-track.
But if you grease the patent office, you can go to the front of the line.
But if back then, if you paid $4,200, you could move to the front of the line. And as a result, his patent issued first.
Oh,
and when that happened, the two women, their attorneys, they filed for what's called an interference proceeding within the patent office. And basically, this is under the old rules before the AIA passed, before the America Invents Act passed in 2013. But I guess it was implemented in 2013. It passed in 2011. But anyway, this interference, the patent law judges that work for the patent office look at all the evidence and they figure out who actually invented it first, regardless of who filed it first. And it's kind of unclear. I think they came out saying that the two women, they didn't take as many steps to enable their invention, and this guy actually took more laboratory steps, and his was more fully developed when he. So they probably invented it roughly at the same time, even though the Dr. Zhang was a little bit later in time than him. But at the end of the day, and they both ended up with a bunch of patents on different aspects of this. So I guess that.
So, I mean, how is this close to becoming relevant? Is this close to becoming something that is a practice, or a semi-regular practice or anything?
You know, there were, and I don't know if they still do this, but you could actually purchase CRISPR home kits for yourself.
I don't think I want to do that to
CRISPR
myself.
home kits. But the thing is, those were the kits to edit the genes of one-celled organisms, bacteria and microbes and so forth. They weren't for editing human. You couldn't edit your little brother or something. But isn't that crazy? You could buy that stuff. And also, every university probably in America and most universities in the world have researchers that are tinkering around with this.
Okay, this is, you've talked about some stuff before that's been kind of, okay, well, if this really, this could be whatever. This just sounds like, all right, I could edit DNA, or somebody that's qualified could edit DNA, and I can make my kid do this, or I can make my kid do that. It's like, okay, I'm going to build the next great left-handed pitcher. Can I get in there and mess around with that? It's mad scientist stuff, man.
It is mad scientist stuff. It's kind of scary, too.
It is.
I mean, especially since it's so, they published this paper, and it's not, once they figured out how to do it, it's not that difficult to do. It's not like quantum computing. Yeah, you need the idea and then a few $100 million to try to implement it, But this, it's a lot easier.
Yeah, it's a lot easier, and also, like I said, the ramifications. If somebody figures out and knows what they're doing and can get in there, and we're talking about people who want to create a master race and goofy shit like that. It's like I don't know. Somebody's got to at some point somebody probably needs to look at this and go, hey, let's slow down and put some regulations on this.
Also,
and I'm not a government regulation guy, a big guy, but okay, we're playing God here.
I got to agree with you, because the more I research these topics, it's like, this is scary stuff, and it's making it hard for me to sleep at night. all these different things.
Well, thanks. Now I'm going to be the same way today when I go and tell my wife about this, and she's going to go, what?
But the drawbacks, there are unintended mutations. Unintended mutations due to inaccurate, editing. You can edit the wrong. These are really small things that we're messing with, on molecular.
Oh, but we can get a home kit to do it.
And then also long-term effects, because they don't know what's going to happen, because they might edit a gene and it might have more than one function. The body's incredibly efficient and it's very complex, and we may do something that we don't realize what's going to happen down 2 or 3 generations from now. That's another one. No. And then also, for individuals that undergo this and animals, they don't the body's immune system sometimes sometimes attacks these edits, and that can cause problems. But that's more for things like their blood therapy, where they're trying to cure sickle cell anemia or something like that.
Well, unlike last time where we talked about crypto and we have crypto ads on our site, you will not be seeing any CRISPR home kit ads on Muddy River News. I think I'm going to draw the line on that one.
Yeah, it's probably a good idea. As much pushback as you had on the other.
Well, anything else to wrap up?
Well, I was going to mention. I mentioned the drawbacks. I was going to mention some of the benefits, and we've talked about some of these already. But one thing is organ transplants, and this is kind of mad scientist shit here, but they've basically created pigs that have DNA that's CRISPR edited that grow organs that you can transplant into humans. And they've done it like kidneys. They're working on pig kidneys, and they've done it a couple of times successfully, and they're improving on that. But that, the light is almost at the end of the tunnel on that, area of technologies to grow animals that we can use for, organ donors. And that's kind of, on the one hand, it's kind of beneficial. On the other hand, it's kind of scary too.
Well, and again, though, but that's I know they've used pig valves in people's hearts and things like that. that's again, there's some things that I think can be for the greater good, and if you want to try to get a transplant or something like that. But we're not. If we're going to start turning pigs into humans, that might not be something we want to do.
Well, probably not. But, as long as they have human-like organs, I guess we'll call it good. But, and then
they
also disease treatment, like cancer is promising, and HIV is promising. And blindness, obviously, or interestingly, is promising. Hereditary blindness is one thing they might be able to treat.
I'm going to put on my Brittany Ashley tinfoil hat and say that we already have a cure for cancer, but we're never going to get it because people make too much money off it.
There might be something to that. I don't know. Just think how much of the financial repercussions that would be throughout the world of medicine if we did come up with a simple cure for cancer.
Yeah.
But I don't know. I'm kind of out. I haven't decided one way or the other on that conspiracy theory. I have the tinfoil hat, but I haven't put it on yet.
No, that one I'm joining the ladies on that one. I think that's out there.
Well, and another benefit is GMOs, because you can not only edit the DNA of animals, but also of plants. And so they can make plants. They can create strains of plants that produce bigger fruit or better fruit. Or maybe even grow in soil that's not, or with conditions like less water that you would need. And the thing about genetic modification of plants is that's been going on for thousands of years.
They still can't make a plant that my wife can't kill, though.
I would
love her to death, but she's got a black thumb.
Okay, well, I can tell you stories about that from my household. But the genetic modifications they've been doing for thousands of years is selective breeding. They'll take the best plants that are the hardiest in conditions, and then take those seeds and then mix them together, grow those. GMOs, then biofuel, and the biofuel they're able to, or they think they may be able to make bacteria that are more heat resistant, and that makes the process of creating alcohol for biofuel more efficient, I guess.
Mm-hmm. Well, that'd be good, actually, because we need to figure that's something that I think could be a really good aspect to it, because that's something I really think the alternative fuels really do need to be explored and be more accessible and easier to use.
And I think that's on the way too. I think that's one that they're going to do. Good. And then this last one will help out with this polyhydroxyalkanoates PHA bioplastics, and it's basically just biodegradable plastics that they'll be able to make using this. Be able to modify some plant genes so that it'll work as a plastic and then degrade as soon as we throw it in a landfill or in the ocean or wherever.
That would be good too. So again, this was fascinating. It's always fascinating. You find such great stuff to talk about, and I appreciate.
It's a fairly new one too. This came about 12, 13 years ago.
Yeah, like you said, they were just recently fighting over the patents for it. So this is something we might be hearing more of in the future, and let's hope that it gets handled the right way. And again, that kind of thing that falls in the wrong person's hands, you don't want any of that. So.
Well, definitely.
As always, thanks again, Scott.
Thank you, Bob.
Appreciate the visit, and we'll do it again next time right here on High Tech in the Heartland.
Sounds good.